Okay, so we're now going to a new section of chapter 5. But on my slide here is chapter 6. Is another part of, you can say as a new section. But on my slide, I put chapter 6, but in your syllabus is chapter 5, under chapter 5. So we'll start to apply equation of motion, which will be, you see this one in your final exam, these slides. Okay, so we'll start to apply F equal to any equation again. Before this, in the previous chapter 5, you learn how the translation happen, rotation happen, how to find velocity, how to find omega, how to find alpha, and so on. Now we want to convert the whole motion for rigid body. We are now in rigid body. And in your island, I already upload this appendix. It's called the Lambert principle. So go and read. Okay, it's I think 2 pages kind of things, but we'll cover in our slides also anyway, right? Okay, we'll start to see the central of mass effect. Central of mass effect, where also part of your final exam question. Okay, we start to look into moment of inertia. Moment of inertia means you put something with a mass and you let go, the object will continue to move because of inertia. Okay, we want to see in the rigid body the effect of inertia. So this is an old engine. This is automotive or locomotive in before they call it car. There's one mechanism here. Later in a YouTube video, you see there is a wheel here, which is, we call it flywheel. Flywheel. This flywheel, the concept is to continue the rotation for inertia. Because your piston is this motion, and then you need to change the rotation into piston motion. So you need that to continue to happen, then you have flywheel to continue to move lah. Okay. So this one is
at Food Panda, we're on a mission to make life
so
delicious.
This one is,
because some days the sun can feel like a lot.
okay, the sound already take out. So the people is just turning this flywheel to continue to fire up. Okay. This flywheel can continue to turn because there is a different mass inside there. Okay. So this one will go home and do it later. So what is important? You need the appendix that I gave you in a previous one, the one that have 2 geometry one. Okay, you need that for this section. Okay. Now you start to see in the 3-dimensional body now, and we start to see the effect of central of mass. This one again, this one will come out in your final exam. Your last question for your final exam. Okay, so so let's say you have a body and there's one piece, small piece of that body with a mass. We call it dm. This is a small piece of mass, and from the center of rotation z, and we measure the center of rotation is r. Okay, or the radius. So we want to develop the equation for moment of inertia. So we're using moment of inertia is given by this integration. You integrate m integrate r square dm. Okay, this is a general equation to calculate inertia for moment. Okay, now moment of inertia, you have to call back the concept of moment. What is moment? What is moment? When you have a reference axis and you have a force, when you have force, let's say force is going down, a perpendicular distance of d to the force will generate moment. Moment from the reference point O here, like what I'll draw on the smart board here. This will be the moment generated by the force, red arrow force here. Okay, the cross reference point here. Okay, this is the concept of moment. We apply the same for moment of inertia, but the word inertia is because of the mass. Mass you can convert into weight later, but to get the inertia, we do integration, means we take the R and the mass in the calculation. So we need the arm multiplied by the mass. Oh. Okay. So this moment of inertia is depend on your axis. Depend on axis, but what is important in this general formula? So moment of inertia give you I equal to integration of R squared dm. Okay. Now for this module, you don't need to memorize the equation. What you need to do is you referring to the appendix that I give you. You only need to know where to look for the formula and also equation. Okay. Even this equation also in, I think, on the top of the, not on top lah, but in the diagram there lah, huh? Okay. So moment of inertia always positive because of the square there. The R can be negative if it's go another direction, but it's always positive. So common unit is kilogram meter square because your mass is kilogram. R is in meter. So you have meter square kilogram or kilogram meter square. So if you have a body of different density, how you find mass? This dm. We start a bit derivation a bit. You know that your m equal to v multiplied by the density, right? There's a formula of velocity, right? You know how to find velocity, right? So if it's a square, it's a cube, then you multiply the three sides, x, y, z lah. You get velocity lah. Now what happens if you have a cylinder? You have pi r square, get the area, right? Pi r square multiplied by the h. So you have pi r square h. Here we have a sphere, 4 over 3 pi r cube. Yeah. So you want to integrate something m, right? So it can be this three form. The object can be a square, a cube that you know is square. You can know that it is a cylinder, or what you see in your appendix. There are 8 shapes that you see in your appendix. It can be square. It can be cone, and so on. So all the formula is inside the appendix. So you don't need to memorize. You need to refer to the correct diagram. So what you need to do is take the formula, multiply by the row, replace here. Replace here, and then this one is depending what you can multiply. So for example, you have a cylinder, h is constant. This height is constant, for example. Then you only integrate r. Put in here, integrate r. Integrate dr. Replace this one, replace this one. And so on. So what is the skill you need here is to transform the general equation into different shape that help you to integrate. So what you need to be careful is the r square. R square need to include into the dm formula. This r square need to include, let's say you have a sphere here. You need to include dm equal to 4 over 3 pi r cube rho. The cube rho need to multiply r square, will give you r power how many? 5. So on. This is mathematics. Okay. So the rest is for your reading. So you convert dm into rho dv. So you're integrating the velocity. And from your calculus or from your mathematics, you know that you can integrate velocity 3 times, integrate 3 times integration x, y, z to get velocity, and so on. But the concept is there. So if your rho is constant, you can pull the rho out from the integration equation. Then you only integrate r square dv. Yeah. Just in case your rho is constant for this module, your rho is always constant. Okay, so here you can see that this is actually purely geometry function. It's in radius, it's in x, y, z, blank, and so on. Okay, so all this is just mathematics, nothing complex to here. Yeah, where got complex? Is you change the mass into rho and velocity. So it's just the shape is a bit interesting lah. Okay. So this is just the highlight that your velocity in 3 dimension, x, y, z. So you need to know how to integrate 3 times your x, y, z lah. Mean this one, the velocity here. Sorry, your volume need to convert into this. You need to calculate the volume first, then only you substitute inside there. Okay. But in this course, you don't need to do integration. All the formula is inside the appendix. Okay, straight away apply, choose the correct shape, apply only. Yeah. Yeah. Okay, so this is just a revision of mathematics, how to find volume. So You can use the first method, we call it shell element. Let's say we have a thickness of y, dy. So to calculate this volume, so what you do, you take 2 pi r, multiplied by the z, multiplied by the y. Okay, so means you take the round circle, the round shape circumference. If you take circumference multiply by the y or the thickness, you get area, right? You get the circumference and then you multiply the thickness dy, you get area. Then you multiply the z, you get volume. So this one is you are using shell element where you look into the thickness changes of dy. I hope you agree. dv volume equal to 2 pi r. Your r is in this direction. Your center is at the center of the object. Your y this direction, z direction, x direction. If you use shell element, you are using dy. Okay. So due to its thickness means this dy, it lie on the same perpendicular distance of r. Yeah. So this is just the thickness shell element calculation to calculate the v. This one. You substitute this whole equation here, d 2 pi y z dy into here. Okay. Then you do integration. First method is use shell element. It's an integration method. Second one, finding the velocity, we use this element. This is for simulation. When you do simulation later, there are two approach. One is shell element approach. One is this element approach. Also finding the velocity. Finding the volume. There are two ways. One is using the thickness of the body to calculate volume, which is 2. This is round one with 2 pi y z dy. Now, if you use this element, we are using dz to generate this first. So the formula will be 2 pi r squared. You get the area of the circle first. 2 pi r is 2 pi y, right? Area multiplied by the thickness dz. You get the volume. So, however, this method is not suitable to find moment of inertia in z-axis. Why? Why is not suitable to find inertia in z-axis? What is different? If you move along this axis, as you change the thickness, yeah. So you look at thickness, thickness, because you are looking at dy, the radius. As you move from z above, you actually okay. So you need to know where is your z-axis, where is your center line of your object, where is the rotation axis. You need to know this object when it rotate, where is the rotation axis? In this case, z. It's like when you draw something and then you revolve it. Where is the revolve axis? If you use 3D software to do 3D modeling, you need to know the axis of revolution. Yeah. Okay, so this is just an exercise for mathematics. It's how to arrive at your first appendix, the one on the left-hand side. How to arrive at the formula below the one on the left, the first diagram, the cylinder one. How we arrive at the first formula. Okay, you don't need to actually memorize, but you just look at the appendix and copy the equation and substitute. Okay, determine the moment of inertia in z-axis. Density is rho, it's not r, it's rho. So if you use shell element, this is just a development of this one. So how do we find volume if we use shell element? We take what? We take the 2 pi, the circumference first. The circumference is 2 pi r, and then we multiply to get the area, multiply by the dr here, and multiply h to get the volume. Okay, so we are using shell element to find the volume. So the mass is rho dv, dm equal to rho dv, and the formula for moment of inertia is I equal to integration of what? Integration of r square dm. Okay, so this one you substitute dv equal to 2 pi r h dr. So you just substitute inside the formula. Okay, I equal to r square dm. You use a shell element. You put in the formula here, and you are actually integrating the radius. So you pull the rho is constant, pull out outside the integration. R square multiplied by r cube. H constant, pull the h out. H do not have r, so pull the h out. So you're integrating r cube dr. R cube dr, integrate r power 4 divided by 4. Okay, you have this one. 2 also pull. Okay, 2 also pull out. Integrate r cube dr, you get r power 4 divided by 4. Simplify, cancel 2. At the end, you arrive at this answer. So Isaac will equal to this equation. You further simplify, you'll get there. This is just elaboration. But can you put this Isaac in terms of m? Means we want to convert this pi rho pi h r4 divided by 2 in terms of mass. What is your mass? Rho v, right? What's your v? So you integrate mass equal to dm. Want to find mass? 2 pi h multiplied by rho. Your r is changing, right? 2 pi r multiply h multiply rho, but you're integrating the r to find the mass. So the m is equal to rho pi h r square. Agree? Why? You integrate this one. R integrate, you get r square divided by 2. Cancel the 2. Simplify, become this one. Right? So your m equal to this one. Just now your I equal to this one. So pi rho pi h r square. Factor this one out. let's say this is already given 300 row there. You substitute x equal to y squared. Oh, familiar. This one is pin ring. Yes, this one pin. Pin means there's a only thickness only. So you use two circular discs, big one minus small one, right? Okay. Then your z-axis as the center. So you're using IZZ. IZZ here. Pick this formula. Yeah. So because it's at the center, so there's no MD square. You're seeing big one minus small one. So you are referring to IZZ formula. Don't use the wrong one. This one comma is at here. Your center is at center. Your center is at here. So your Z is here. So you're using IG is the first one. What you see on the appendix is IG. D is not moving. Okay. So you copy, you copy, and then your D's you can calculate. Okay. M is rho V. R you copy. Yeah. And then also substitute, you get another value. So take the big one minus the small one. Yeah. Huh? Huh? Uh, can someone verify or not? If you take 8,000 here, V you can calculate. V will be what? V will be pi r square. Thickness is 10 mm. You need to convert into meter. Can you verify this value outside? Can you verify? Do you get 1.4? Yeah, once you verify, we call it a day. Okay. 5. Rho is 8,000. P is 2 pi r square. R is 0.28 square. Multiply by r square. Okay. We will back to this example again.